Have you muted this one or still it is echo? You muted this one? No. All right. So good morning and welcome all the distinguished guests and dignitaries on the dais and the audience and my dear students and participants, national and international. We welcome you to this hands-on workshop on this liberation, extraction and fair use of data. It sounds like some revolution in the country, liberation and extraction, but the data also needs liberation. So, and it is hosted at NIPGR. So on behalf of the organizers and the host institute, I welcome you all in this workshop. Yesterday, Gitanjali briefed me about this workshop and this subject. And when she was talking that, I imagined that when I started my PhD in 1990, so at that time I was told to work on a single gene. And at that time, I have seen my teachers, they have spent their life working on single gene. And later on, people told us, no, one gene does not work alone. So it works with other genes. So you need to sequence the genome. So I started sequencing genome and I got thousands and thousands of genes and tried to understand the interaction between the genes and the proteins. In the midway through, people told me, no, you cannot work with only one species because there are a number of species. So far, I was working on one species. So you have to work on different species. So you have to take care of the biodiversity. So then, obviously, it is beyond my capability. So I looked for these people who has a lot of biodiversity. I work on chickpea, sometimes in other crops also. So I took the materials from the Indian, the Council for Agricultural Research, lot of biodiversity. Then I started sequencing the different species and the different varieties within a species. So I started working on the interaction between the different species. Now people are saying me the static biodiversity is not enough. You have to work with the dynamic biodiversity. What is the dynamic biodiversity? Generally, when we take the data of a biodiversified spot, or India is a great melting pot of biodiversity, then we take the static data. At that time, what is the data? Now, there was a meeting in Department of Biotechnology, which was the parent ministry of NIPGR, that there will be dynamic biodiversity because the NASA and ISRO has together made the synthetic aperture radar, and they are putting it on a low orbit satellite. So that will move over the India and through the equatorial region, and they will take the snapshot every half an hour or 15 minutes or whatever we decide. So then we can get the dynamic biodiversity of the earth, especially for the India. So from a single gene to multiple species or biodiversity to the dynamic biodiversity, obviously there will be humongous amount of data which one brain cannot fathom. So we need the computer, and beyond the intelligence, we need the artificial intelligence. I hate the word artificial because that castigate that one subject. It is basically, it will be the real intelligence at one time. So although the human will control it, but it will be the intelligence system which can work across the field, diverse field, and can give you the human readable data. Generally, we get the machine readable data, we get the digitized data, which generally, the main thing is the democratization of science. The science develops only when we democratize science. That means if the fruit of the science reaches to the common people, then only it is a democratization of science. So I always said that among all the discoveries, the printing press is the biggest discovery. because previously people do the calligraphy, people used to do the calligraphy, copy the book and then distribute, and it reaches only a few handful of masses. So knowledge was restricted within a handful of masses. But when the printing press came in the 14th century or 15th century, most probably 1414, then the books were printed and it reached masses. So the knowledge was democratized, and this after effect is the industrial revolution in Europe. So that is the effect of the printing press and today's mechanized civilization, whatever you say. So that is the effect of the printing press. So it should reach masses. So for that, not only the AI, it has to be the language models which are required so that. And the job is to exactly what is written here: liberation, extraction, and fair reuse of the data. So, and this time the case study will be the biodiversity. The main problem is of this subject is this biodiversity data has been captured over the years, rather over the decades. Started from the biodiversity, is a very old subject. That's the Charles Darwin. It started from Charles Darwin. And the technology changed, and the quality of the parameters used to capture those data changed. So how can you compare that day's data with the today's data, which is highly digitized and after application of a lot of parameters? So that will be the challenge of these computer scientists, and that's why the artificial intelligence will come. Whether we can take those data to our confidence, or we have to again assess those in today's parameters, but we have lost the time. We are not in the Charles Darwin days. So how to do that? How to bring them to the same technological platform or same knowledge platform? So that will be the challenge. So, and the more and more challenge and the more computation will come. And this knowledge, and especially the taxonomic and the ecological and the distributional information, these are locked in the scientific literature. You can talk about our ancient literature also, but those are not validated by experimental. Main problem will be also the references. On what references we can tell them this is a validated data. So this validation, bringing them to the same platform, technology platform, and then to interpret that data and transferring that data with a very common, I would say, regional language. India has a 22 scheduled language. To regional languages, and with a common, normal, colloquial language, query will be the normal language, answer will be in the normal language. So that will be the challenge. There's a huge work, probably the 1 decade or 2-3 decades will be required. And obviously, if you want to reach common people, you need the communication tools. That's also one computational challenge, how to reach them. And you have to cross the language barrier, how to do that. The main problem of AI today, it gives you answer like a human. So that is also one problem, because human never gives the correct answer. Human always weighs all his experience and give you the putative answer, which is close to perfect. So this scientific knowledge cannot be close to perfect. It has to be perfect. People are very enthusiastic of using AI in medical science. I'm very skeptic about it. I'm skeptic about any new technology that will diagnose. But the problem is, if diagnosis fails, if it is a wrong diagnosis, who will take the responsibility, AI or a human? It will go to court. In court, you cannot call AI in the witness box. So who will take this responsibility if the knowledge or the message is imperfect or close to perfect? So there is no doubt about that close to perfect and the perfect knowledge. So there, I don't No, the machine learning can give you probably the perfect uh, knowledge, but AI, I'm not that very enthusiastic right now, the present technology. It gives you very close to perfect information, not the perfect thing. The reason is the machine learning probably can handle millions of data. Now, whenever it is billions of data and you have to run the program every day, you have to fire the program every day, then you have to obviously give this responsibility to AI that it will automatically fire this program and will do that. So whenever we fire a query, logic query in AI, it starts the programming, right? So that automatically does. So when you will have the billions and zillions of data, then you will have a trouble, and then AI will run it automatically, and obviously the users will search for the knowledge or answer within a second. Within seconds, how to search your all databases and give them a perfect answer, that will be the challenge. But that challenge will come later on, when you liberate and extract and reuse the data. So first you better meet the challenge. What is how to extract the data? That is the first stage. I hear Gitanjali here that they have extracted some Charaka Sanghita and some. But the point is, the question came from our scientific advisory committee. Okay, Charaka Sanghita, that data was there. But where is the validation? Because you cannot give people the unvalidated data. So that will be another challenge. Extraction, liberation, fair reuse, fine. You can do it with artificial intelligence or computation. Communication in regional languages, you can do the large language model and you can do that. But the validation and the perfection, that will be the challenge which the computational scientists should start thinking about from now. So that will be the challenge. Whenever you come up with some workshop, I throw you people a challenge, and which is not good for me and good for you also. But I welcome these international experts and the CODATA to partner with this one. And I am just hearing the new some jargons which is called plazi. Yeah. So I am not very sure about it. What it, I hope that you people know at least. And I acknowledge the collaboration with the CODATA India and the plazi, as well as the participation of the international experts. So such partnership, basically, it is not a job of a single country. It is. I remember that when we started the tomato genome sequencing, it was 10 countries. So I traveled in 3 or 4 of them, and together we assembled the tomato genome in 2007. So when a new subject starts, then you need international collaboration, but very slowly, this global village concept takes the back seat. Every country starts its own. And, but right now it is a very new subject. We need the international collaboration. So for that, we thank you and express our gratitude that you have come here to share your knowledge with us. And in addition to the integration of the AI and the computational tools for the knowledge extraction, it is an important direction in the future. Basically, whenever we will apply some knowledge, any scientific knowledge, it has to be the holistic. It should include not only the biodiversity, the dynamic biodiversity also, because it changes in seconds. The birds' movement, the honeybees' movement, so that changes in seconds. So now how they are collecting the pollen and where they are, because you can trace their path. So this kind of data, when it will mix with the gene, single gene, and this huge diverse or dynamic biodiversity data, then only you can give a clear picture to masses that how they should do the agriculture, how they should take care of the environment, and these are all related with the medical and health science. Ultimately, it is for our benefit. We are not doing any benefit or we are not obliging the nature, basically we are getting benefit out of it. So this is not for helping others, it is for our survival. So if you think about that in your mind, then obviously your endeavor will be successful. So I encourage all the delegates to make their most of this opportunity, and the workshop will not only offer the theoretical insights, but also the hands-on experience. That is a nice one. And the tools and workflows that are increasingly important in this modern research. So that was, I could thank you. And if you have any problem, I'm just one story ahead, so you can come to me. Complain against Gitanjali or complain against me. Thank you.